Okay, so I know it's kind of trivial. Try the warm up. It's relevant to calculus. A square is rounded. That too. Um, and this is the last concept in chapter 7. So, and it's short. So we'll do this today, and hopefully, Spencer, sit in front of this. Um, yeah, so hopefully we'll be able to get through some of the homework on this today. And tomorrow is review for whatever you want to know or ask about on chapter 7. Cool, yay? Rock? Yeah, you can use a calculator on this. The numbers are a little high.
It's like it's medium and it's on the graph. So there's the 12.
Good morning, BCC. This is Jed Sadke with your daily announcements. Today is Wednesday, February 8th. Please stand for the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Hey, volleyball players, we are having a varsity co-ed volleyball.
So, what's the answer? 37. And how did you get it? Pythagorean theorem, well, yeah, but exactly what you did was x value minus x value squared plus y value minus y value squared under the square root, also known as dx and dy, right? Change in x, change in y, yes, Pythagorean theorem.
Why didn't we call it that last year?
Well, because y'all didn't in geometry when you did this, I don't know, out of the womb, because you guys do that so soon, you didn't understand what d meant so much as difference. But, okay, so today we're going to do integration of Pythagorean theorem to find the lengths of curves. Smooth curves, and sometimes we can do it at pointy parts because you can find the length of a straight line that makes a corner. Okay, so like we just did with the triangle on the first thing, we did Pythagorean theorem, so that was dx squared plus dy squared under the square root. Kind of weird.
What do we call that?
This
equals dh.
this is distance formula or Pythagorean theorem. What do you mean? What do we call that?
I don't know, like if you would say like we're solving for like distance or something.
Okay, well, hang on.
Like r.
It's kind of weird. Okay, I'm factoring dx squared out of a place where it did not exist. It's just a little strange. And then square roots, you know that I can pull it apart. What is dx squared over dx squared? Hey, we have a name for dy over dx. That's like the slope, the derivative, yeah? So the length of any triangle is the change in x squared plus change in y squared. And then, Connor, now I'm doing funny things to get a formula that I want. Square root of dx squared What is that?
dx.
Dx. Oh, hey. Huh. If you want the length from A to B on any curve, there's your formula. Square root of 1 plus derivative squared. All of it is. Yeah? Ooh, crazy. Write you in hard heavy. And it is very rare to find one of these that works nicely without a calculator, so most of these are calculator questions. So the test that you guys have on Monday, part of it will be with calculator. My least favorite kind of test to give is one that's got 2 pieces. So the way I do this is I will give you both pieces at once. One is on a colored sheet of paper. When you have a colored sheet of paper, that's the one that needs the calculator, but you need to turn in the white sheet of paper before you get the calculator out. Because I want you to see the whole test, and you can set up the majority of these things, and then at the end, you can just do the type. So,
So this is a test that will take just 1 period.
Yep. Chapter 7 isn't a whole 2-day kind of concepts thing. I mean, we did area between curves. We spun some things around the x-axis, around the y-axis. Sometimes they had a hole in them, sometimes they didn't. Sometimes they were triangle shapes popping up out of some other solid on the ground. But that's it. Okay. There's the formula. Typed. It's the same thing. In case you missed it from the last page, there it is again. Really? People are writing it again? You don't have to have the boxes around it. That was an accident. So let's try a problem. That's all I'm telling you. And it is a calculator question. So try it. What's the period of a trig function? This particular.
0 to 2.
Okay. So,
Okay.
oh my goodness, prior knowledge, we have it. Yes.
Oh.
Yeah, I said calculator. It is hard to get these to come out nicely. Yep, need to be in radians.
Can I just do this over?
Yes, no? So it's the integral from, it says the length of one period of the sine curve. So this is not that straight line. You had to go the wiggle up and the wiggle down. So as if you had a rope that traced that out, how long is that rope is what we're calculating. So the formula we just derived, 0 to 2 pi, because that's the length of one full period, square root of 1 plus the slope squared, all under the square root. Does this have a trig identity, and can I replace this with sine squared and do the square root of sine squared and get just sine? No, because what's the identity? 1 minus. Be careful. It looks super close. Very small difference, and it makes all the difference. Okay, so did anyone actually successfully type this in? What'd you get?
7.6404.
7.6404. Well, let's check. Hitting math 9 is integrate, and mine is yucky. These are hard to type in correctly. If you have a TI-84, it's much easier, but so square root. And I'm going to do the cosine first. Cosine x, close the parentheses, squared, plus 1. Is it okay that I traded places? A plus b is the same as b plus a? Okay. Okay, I need to close the parentheses around the square root, comma x, comma 0, comma 2, pi, close the parentheses. Huh, I didn't make a mistake. That's amazing. And I get 7.64039 something or other. So the only answer that is correct is 7.640. You could keep extras, but 0.641, wrong. 0.64, wrong. Okay? Anyone having issues with the calculator? Try doing that one then. Find the length of the curve, y equals x squared, from 0 to 1.
Integrate x.
Integrate what?
X squared.
That's an x squared, sorry. So Reese, what do we do?
You integrate from 0 to 1 square root of 1 plus 2x squared.
Be careful, it's 2x squared, which is not 2x squared, it's 4x squared. So typing that in on the calculator, I kind of recommend you do the 2x times 2x and get 4x squared, because otherwise it's a pain to type. Anyone get it yet? Nicholas?
1.478.
1.478, so let's check. Integrating square root of 4x squared plus 1, close the parentheses with respect to x, comma 0, comma 1, close the parentheses again, and 1.478, or that next number was a 9. So both of those would be counted as correct on the AP exam. Everybody okay with, who doesn't have a calculator and is not practicing this? Nobody's admitting to it. Okay. All right. That's x to the 1/3. Bless you. Yeah, so what are you guys getting? Undefined. What's wrong with this? Nicholas?
You just went negatively delete, just like split up.
Okay.
It can't go at 0.
So there's a symmetry to this. So maybe I can cheat the system and go from 0 to 8 and then double it.
It's 0
Oh, is that one gonna work?
to 0.
I've never checked this calculator. I think I might have broken it. Spinning, it's spinning, it's spinning.
It's not happy.
Yeah, it's gonna be there a while. I think I'm gonna run down the batteries. Broke yours too. Okay, what's wrong? Ben said the derivative is not defined at 0. Are we integrating over that in past? Yeah, so that's a problem. We have a vertical tangent right here.
So what? That's got no area.
Oh, it's got, okay, yes. And sometimes infinity in the middle of known numbers is a problem. And it's making my calculator, first it broke, and now it's like, I'm thinking, it's calculating to infinity, it's working really hard.
Just give it like 10 more minutes.
And those of you who don't know this, hit the on button. That's the break. That says, stop, Mr. Calculator. I would like to move on and try a different problem. I'm giving up on this one. I picked C, moving on. Like, hit the on button. Otherwise, you're going to like panic in the test and take your batteries out to turn it off and then put it back in. So the way we do this,
Ms. Pascal?
Yeah.
But if you do it from 0, doesn't that include the place where?
yeah, it's still a problem.
So that's why it wasn't.
That's why it's still not working. But it was interesting that it was trying to start at infinity, and that's why it was like spinning forever. It's like, I'm getting there. I'm at 2,000 now. I'm still working. Okay, I'm at 2 million. It's going to be a bit. So you got to hit the brake. All right. So the way we deal with these, and you know, I say this every time, like, I've never seen it on the exam. It'll be there this year. It'll be there because I say that it's never there. Well, we can't integrate over that vertical tangent. So how about we turn it sideways and be like, maybe I will do this with respect to y. Oh, coy, it's not that bad. The way that I developed the formula that we used, I did this. Well, what if I divided everybody by dy squared? I mean, this is weird. Saying dx dy, but if you ask any runner how fast is your mile, That's time per miles versus miles per time. Like normally we say, driving at 55 per hour. Right, honest officer I was. Versus, yeah, I run a 412 mile. Those of you who do. Yeah. So I can do it upside down. So same idea. Dx, dy. It's uncomfortable and weird. Naomi, what is dx, dy? Derivative of
3.
multiply by the power, lower the power. Like, it hurts. So then we're going to integrate, and what are we going to set up?
From -2 to 2,
So the y value is -2 to 2, and what's under?
and then 3y squared all squared.
Okay, 3y squared all squared, so 9y to the 4th plus 1 all under the square root. Check to make sure that you get that answer of 17.260 or 17.261.
I got that answer.
Seth got that answer and polished off that power bar, or not quite. Still working on it. That Z bar.
Miss Fesco,
Yep,
I got my calculator to graph something. I'm so happy.
you got your calculator to graph it?
Well, no, but I finally got it to graph something. After all these years.
Looks like you're in radians or degrees.
Yeah, the equation's like completely wrong. So graph something.
Wait, so specifically,
Yep.
if you flip that, you have a horizontal tangent and then
Horizontal tangents, I can go right over a zero tangent. I do that all the time.
Exactly. So can you do the 0 to 2 then?
You could do 0 to 2 and double it because there is a symmetry mill. You don't. So you just use the variable key, which is the x. So my calculator, I can use any letter I want. Your calculator, you have to use the one that they declare. So you wanted it, T for time, you're using X. It's Y for, Y, you're going to be using X. Did everyone get that number? Anyone have trouble with it? No one else's calculator barked on this? Okay, so here is a free response question related to arc length. This is a BC topic only, by the way. Here you are. You have completed AB calculus, and now you are strictly into BC calc territory. Try this problem.